to take a look at a couple of regression problems, a little warm-up problem, and then some of the what I considered advanced regression examples. So things that we're only going to worry about in rare occasions will they be asked, but it's a really great thing to know once you've kind of finished your other studying. So it tells us in the university tab containing the daily sales of coffee shops in dollars, population of the city the shop is in, the monthly advertising budget in dollars, the average income in dollars of residents, whether there is a competitor close by, and whether there is a university in the area. Use the model to explain daily sales as a linear function of a constant, the population, advertising budget, and whether the university is in the area, whether a university is in the area. So anytime it talks about running a regression with a constant, all that means, and we'll just scroll down here to see, hey, we've got our regression outputs, is that we have an intercept. And regressions are going to have intercepts regardless. So them saying that doesn't really change anything you are going to do. So we can see here that we have our regression model, sorry, excuse me, and that under the coefficients, this is really where our betas are coming from, right? Just to remind us that that's where our actual model is coming from, that we are going to or could use the p-value to tell us whether or not the beta is a valid thing. We can use our overall significance by using the f-test, and so we have the p-value for the f-test. The Anova table we've looked at about the calculations that happen there, but what we're talking about, just, when you're getting your bearings here, it might be nice to recognize that under that degrees of freedom for regression, it says 3, and that's because we have 3 variables going on in this problem, right? We had population, monthly ad budget, and whether or not there's a university that's close, and so that's where this 3 came from. It goes with the fact that there are those 3 below, okay? And so let's take a look at the actual questions that were being asked here then. So the first question asks us, is the model significant and what is the p-value? So anytime we're talking about the model being significant or overall significance, we're talking about the f-test. So different than our f-test for determining whether variances are equal or unequal, the f-test in our regression is that test to see whether all the coefficients are 0 or at least one of them is not, right? The null from that is basically that all the coefficients are 0, meaning you've got some equation like y is equal to 100 plus 0x plus 0x plus 0x, and that doesn't help us, right? That basically means that nothing we're doing in any of our x variables is helping to explain y, and the alternative is that at least one coefficient is relevant or is not 0. So when we look at that, we see that we have this p-value of 1.31 e to the negative 40. So our p-value there, this 1.13 times e to the negative 40, that is basically can be interpreted as a 0. And anytime we have a small p-value, right, when we've got that p-value less than alpha, and it would not even matter what alpha is because that p-value is so small, it means that we can reject the null hypothesis. And anytime we can reject the null, remember this null is saying, hey, your whole model is crap. And we're like, no, we're not going with it, we're rejecting you. So we are going with there is something significant here. So whenever we go with that alternative, is the model significant? We can say, yes, the model is significant. And that's because of our trusty p-value from the f-test. The next question asks us, what is the percent variation in sales, which is explained when taking into account the number of X variables? So we want to recognize here that sales was the Y variable. That's what we were predicting. So when we're talking about the percent variation explained in our Y variable, we're talking about R squared. When we talk about that, but also taking into account how many X variables we have, or sometimes we'll talk about, holding constant the number of X variables, some kind of reference to the number of X variables, what we're actually being asked about here is the adjusted R squared value. And so our adjusted R squared value, we can get that from our regression statistics. So you can see that we've got R squared there, and then we have the adjusted R squared. And adjusted R squared will always be a little bit smaller than R squared, sometimes only by the, fifth or sixth decimal place. But our adjusted R squared here is 0.465. And what this is really telling us is that about 46.5% of the variation in sales is explained by our model. Now, this 46% might be amazing if you have, if you are looking at something where every model that you've run until now only gives you 10%. Oops, sorry. But typically we're looking for something better than 46.5, right? This is basically saying, hey, we've only accounted for about half of what's going on with sales by using the variables of population, ad budget, and whether or not there's a university close. So there's something else going on in this problem. So the last question here is, what is the 95% confidence interval on the impact of a university being in the area, and is it significant? So anytime we're talking about a confidence interval, those are typically given to us in our output here. In a second, we're going to go over how we could possibly calculate ourselves. But if we were talking about whether or not a university is close, we're looking at our last row here. And what we're really looking at is that confidence interval given at the end there. So it tells us that the lower bound there is 1615.39 if I round that. And so that is the lower bound on that third coefficient, and the upper bound is 2128.95. And so really, we can interpret these this confidence interval as almost like the range of possibilities. Sure, our model has come out and said that they think that the impact is 1872. If a university is close, sales are going to go up by $1,800 there. But really, that's not for sure. It's an estimate, and there's always some uncertainty around estimates. And so when we get these confidence intervals, they're almost like ranges of those possibilities. And so it asks us, and is it significant? Well, what we want to recognize here is that things are not significant when they equal 0, okay? That's the whole idea. We want to reject the nulls because the nulls are all, hey, this value is 0, and we want to reject it so we can say it's significant. So in this case, this confidence interval, it does not contain 0. And because it does not contain 0, this means that, well, our coefficient can't be 0, and therefore, yes, it is significant. So what I have on the next page for you is an advanced example, and well, advanced depending on kind of what your perspective on regression is. But what we have here is a bunch of missing information, and we're going to take into account a little bit more of the behind the scenes work that goes into regression output than we do in a standard problem. And so these aren't questions that typically come up a lot, but it's just that like one-off curveball. If you want to be prepared for everything, here we go. And so it says a model to predict weekly sales in dollars of spaghetti at 60 grocery stores was run using the explanatory variables of population in the surrounding area in thousands, yes or no, high income area. So when we see that kind of yes or no situation, we want to make sure we're recognizing that that is a dummy variable. It's going to be a 0 or a 1 type variable. And total sales in like of the store in 1,000. And so it's given us partial regression results. So we don't have the full information of what's going on there. Okay. So the first question, it asks us, can you reject the null that beta 0 equals 0? So typically, if we wanted to do this, we would just look at the p-value that went with the intercept. The fact that it says a little 0 here means that we're talking about the intercept. We don't have a p-value. We've got a coefficient. We're missing a standard error. We've got a lower 95% and an upper 95%. So instead of using the p-value as we classically would, we can also use the confidence interval, right? Our confidence interval for beta 0 ranges, the lower limit is 1,000 and the upper limit is 3,800. So when we look at this, there is no 0 in the range. And because there's no 0 in that range, we can say that beta is not 0. There's no 0. Remember, that confidence interval is more like a range of possibilities. Beta 0, yes, we've said that it's actually, 2,400, but really could go anywhere from 1,000 to 3,800, but it doesn't really matter because that doesn't contain 0. So can we reject the null? Yes, we reject the null that beta 0 equals 0, as beta cannot be 0. Part B says, is the impact of population statistically significant? I.e., can you reject the null that beta 1 equals 0? And so when we look at this, we're like, great, we just did this for part A, but then when we look at population, it didn't give us a confidence interval. And in fact, it asks us specifically for what is the p-value associated with this. So we want to keep in mind that anytime we get a p-value for our for those coefficients, it's really running that hypothesis test that coefficient, and in this case, because we're working on population, it's going to be beta 1 equals to 0 against the alternative that it does not equal 0. That looked like a 2, sorry. 1 does not equal 0. So it's a two-tailed test, and we want to keep in mind a couple things. The T formula or transform for this is beta hat minus beta over the standard error with degrees of freedom of n minus k minus 1. These are just from our formula sheet, but we're going to make use of them. So from our model, it gave us the coefficient value of 2.41. This is our sample data for beta 1. It's what we think beta 1 should be. And it also gave us the standard error. And so we're going to put both of those things to work. So when we go to do our calculation of t here, right, our beta, 2.41, the other beta, well, that is coming from our hypothesis. We currently believe it should be 0, and the standard error, just 1.3. For our degrees of freedom, well, we need to know what is our sample size n. And if we go back up to our problem, it says that we use this model at 60 grocery stores. So we've got n equal to 60 there. K is the number of X variables we have. And so in our model, we had population, high income, and total sales. There are 3 X variables, plus minus 1, gets us degrees of freedom 56. So we have a t-value here of 1.85 with degrees of freedom 56. And we're going to use this to calculate our p-value. Now remember, this is a two-tailed test. We've assumed 0 is the middle. Our t here, and this is a t observed value, it's on the positive side. It is 1.85. And we can find this area here, but keep in mind, this would be a one-tail p-value. And this is, in fact, a two-tail test. So if I wanted to find our p-value in this problem, remember that two-tail p-value, and I'm actually going to be explicit about this, our two-tail p-value, which is what we need because this was a two-tail test, is just twice whatever the one-tail p-value is. So just 2 times, and then what's my one-tail p-value? Well, in this case, that one-tail p-value, it's an upper tail, so it's a 1 minus, and we're going to go t dot dist, and we put in our t-value of 1.85 with degrees of freedom 56 to get our calculation there. And this is going to come out and give us a p-value of 0.0695. And so because we are dealing with an alpha of 5%, and they didn't explicitly say alpha of 5%, but the fact that we have a 95% confidence interval tells us that alpha is 5% here. And so our p-value of that 6.95% is bigger, just slightly, but bigger than an alpha of 5%. So in this case, we are going to not reject the null. And if we don't reject the null in a regression, this means that it's not statistically significant. Right? We're saying, hey, that relationship, right? If that coefficient might as well be 0, if we can't reject that null that it's 0, then we probably shouldn't be including that variable in our model. C asks, what is the 95% confidence interval for the total for the impact of total sales on weekly spaghetti sales? And so when we're doing a problem like this, right, when we're talking about regression, we're talking about a, for our confidence interval, it's on our formula sheet, that the confidence interval is going to be beta hat plus or minus T alpha divided by 2. Again, our degrees of freedom here are going to be that n minus k minus 1 times our standard error. So if we're looking for that 95% confidence for the impact of total sales, we're just going to plug into our formula here. The only thing we really have to do is find our t-value. So like any confidence interval formula, it's really get the formula you're going to use, get the t-value. So in this case, our t-value here, right, we're going to use a t dot inverse. It's a 95% confidence interval, meaning alpha is 5%, but we're going to split alpha into 2 tails, as we always do for confidence intervals, 20 or 2.5 there, and our degrees of freedom still 56. That didn't change on us, and it gives us a t-value of negative 2.003. And so now we just have to get the rest of the information from our output. So for the impact of total sales, when we go back and we look at total sales, it gave us that sample beta 3, and it gave us our standard error there. So we're going to use 3.1 and 0.95, and we're going to build that confidence interval. So we've got 3.1 plus or minus 2.003 times that standard error of 0.95, and it gives us our, confidence interval here, the lower bound being 1.197 and the upper bound being 5.002. 003 there. And so what we have, right, we've got this interval. We can see, if we wanted to do a follow-up question, that beta equals 0 is not in the interval. And so we have, we could say that this is statistically significant if that was the question. They didn't actually ask us, but if they wanted to ask us, we could also conclude that it is statistically significant. So when you take a look and you see something that is abnormal like this, we can pretty much figure out anything we wanted to from these problems. The question didn't ask you this, but what if we wanted to know the impact of being located in a high income area? Well, if we were worried about like what's that impact is somewhere between -600 and -400. And in fact, the coefficient is always going to fall between the middle of that lower and that upper. So it would be -500 here if we needed to come up with that number for a certain reason. So just remember that the actual coefficient is always going to be the center point of a confidence interval if you need that as well. If you have any other questions, as always, feel free to send me an email or, in all honesty, send me a Facebook message and we'll go from there.